All right, so we're in section 7.7. We're going to graph inequalities. So no matter what kind of inequality that you're going to graph, whether it is linear or whether it is nonlinear, the steps are the same. And so there are 3 steps. I recommend using these 3 steps so that you don't get goofy with the inequality sign. So step 1. Step 1 is always to graph the equation. We're going to call that equation the boundary. Okay, so I've picked this one intentionally because this semester we have not done a lot of graphing of lines because that is covered quite extensively in intermediate algebra. So I just want to remind you of the key concepts of graphing lines. So I've got x plus 4y equals 4. So first thing I'm going to do is I change the inequality sign to an equal sign. And now if you remember your graphing of equations, or linear equations, I'm going to solve this for y. So I can find the slope and I can find the y-intercept. So I'm going to subtract the x. So I get 4y is equal to negative x plus 4. And then I'm going to divide everything by 4. Key step, don't forget to distribute that 4 to all the terms. So I've got y is equal to negative 1 over 4. X, and then 4 over 4 is 1. So what this tells me, this is slope-intercept form. So what this tells me is my slope is negative 1 over 4, and my y-intercept, where it goes through the y-axis is 0, 1. So now what I'm going to do is I'm going to go to my graphing board, and I'm going to go ahead and plot points that represent this. Now here's the key. Don't connect the dots yet. We will come back for step 2. So at the graphing board, we saw that the y-intercept is 1. So I'm going to make a dot at 1. Then my slope is negative 1/4. So I'm going to put the negative with the 1 with the numerator. And remembering that slope is always y over x. So negative 1 over 4. So negative 1 means down 1. And then 1, 2, 3, 4. I'm going to make a dot. Down 1. 1, 2, 3, 4, make a dot. I could have gone up 1 and left 4. It's all the same thing. Now, here's step 2. Step 2 to graphing any inequality is, am I going to graph using a solid line or a dotted line? Meaning, is my boundary going to be solid or dotted? And so what a solid line represents is that there is equality, meaning the boundary is also part of the solution set. Okay? A dotted line means the boundary is just the boundary, dividing the 2 sides of the Cartesian plane, and it's not actually part of the solution set. So if you remember, if you've written it down, the inequality we are graphing had a greater than, so there was no equality. So what I'm going to do is I'm going to connect these dots with a dotted or a dashed line. So here goes. All right, so there's my dotted boundary line. So I've got one more step. Step 1, I graph the equation that forms the boundary. Step 2, I either connect the dots with a dotted or a solid line. Step 3, so I'm going to come back over to my board. Step 3 is I have to decide which side of the boundary I'm going to shade. Because now that I've divided the Cartesian plane into 2 halves, it's either one side or the other represents the solutions. Now please, 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 do not assume that because there's a greater that always means to shade above. It does not. I could change a sign and I could make this shade below or above. It does not matter. So do not be fooled and just automatically shade above. So what I'm going to do is I'm going to pick a test point for step 3 is we pick a test point not on the boundary. So I'm going to go back to my graph. And what I'm going to do is I'm just going to look, is there a point that is nice and easy to plug in that is not on the boundary? So I'm going to either test a point above the line or I'm going to test a point below the line to see where the solutions are. Now, my favorite point to test, if it's available, is 0, 0. It is on this, so this is going to be my test point, okay? So I'm going to test 0, 0. And what that means is this. I'm going to plug 0, 0 into my inequality. If it gives me a true statement, that means all the solutions are where the test point is. If I get a false statement, that means that this is not a solution and the solutions are over here. So coming back, sorry to make you dizzy if you're getting dizzy. So here we go. We are going to test 0, 0. So here it goes. I plug 0 in for x, and then 4 times 0 is 0. Oops, that's not what's on the other side, and there's a 4. So here's the question. Is 0 greater than 4? And that is false. And so what that conclusion means is this, and this is the final time that you'll have to slide over. I tested the point 0, 0, right where my finger is. I got a false statement, meaning 0, 0 was not a solution. So what that means is none of the points down here would be a solution. You could have picked anything and it would not have been a solution. So the conclusion is the solutions are above. So I'm going to do some form of shading. You can see I'm real meticulous. And that is how you graph an inequality. Where the shading is where the solutions are.